Hello! Today we're going to talk about the analysis of microplastics with FTIR microscopy. There are several different types of samples, like bottled water that just needs to be filtered and then can be analyzed, sea salt or table salt that can be analyzed towards its content of microplastic that needs to be dissolved first and then can be filtered, or more complex samples like sediments of riverbed that need pre-treatment like enzymatic digestion or oxidative treatment. And we are going to focus on the analysis of the sea salt sample with the LUMOSII V2. So we're going to dissolve it and then filter it, and for this we need to go to our laboratory. Okay, we're now in our laboratory and we're going to take care of the sample preparation. So that means we're going to dissolve our sea salt sample in distilled water and then filter it through aluminum oxide filters. There are several different filter types like silicon or gold-coated polycarbonate, but we will be using these. Okay, so I'm gonna put this away and gonna pour our salt sample into the beaker and then we'll dissolve it in distilled water. So now that our sample is dissolved, we're gonna filter it using this apparatus. This is offered directly from Bruker and consists of the suction flask, this rubber stop and the glass fridge, a pack of filters, this clamp and the cylinder on top. So to prepare it, we're gonna take an anodisc filter, place it on top of the glass membrane, put the cylinder on top, secure it with this clamp, and for easier filtration we're gonna use this vacuum pump. So now that everything is set up, we're gonna fill in our sample. And turn on the pump. After our filtration is done, we can remove the top cylinder by removing the clamp. And before we can start our measurement, we're going to take the filter and leave it in the oven to dry. Now that our sample is dry, we can place it in the filter holder to fix it for the measurement. It's an easy to use tool. You just lift this clip, place the filter, release, and you can place it onto the microscopy stage. Okay, we are ready for our imaging measurement. We already placed the sample on the stage of the LUMOSII V2 FTIR imaging microscope, and we're going to use its focal plane array detector for the measurement. This way we have a far better spatial resolution and measurement speed than any line array detector could offer. We're going to measure the whole sample, and this technique is especially suited for samples with a high load of particles. So by measuring everything at once, we're not going to miss anything that might be on there. And in the end, the analysis is also automated, and this way we can reduce the human error. In microscopy, it's very important to see what's happening to your sample at all time. This is why we have this dual monitor set up. And on the first screen, you can always see your sample and what's going on with it. And the second screen to go through the guided workflow of the spectroscopy software. Now, in the analysis of our sample, the first step would be to take an overview image of your sample. If you're not interested in the overview image, you can just skip the step and go directly to the analysis. When the recording of the overview image is done, we're going to go and define our measurement area. After we have collected the background, all we need to do is define the measurement area. Our parameters have been set to predefined values and can be changed here. Now we just place an FPA grid over the area we want to cover, and the software will give us the corresponding number of tiles we need. Each tile consists of 32 by 32 pixels and has a spatial resolution of 5 microns without binning. In the final step, we give the sample a name and can start the measurement. In this screen, we will see the movement of the stage as well as a live image of the measurement on the left side. After the measurement is done, we are directed to this window where we see the result of the live integration displayed for the whole measurement area. We see that there are two larger particles sticking out, and we're going to have a look at them first. Just by clicking on the particle, we are shown the corresponding spectrum, and if we want to identify the particle, we just perform a library search. The suggested identity of the particle is displayed here, and in this case we can be sure that it's polyamide. If we now want to see also smaller particles, we just decrease the color scale and we will see that there's a lot more. And again, just by clicking on a particle, we are shown the spectrum, and to find its identity, we perform a library search. And in this case, the particle was identified as polypropylene. What is impressive in this case is that we only measured with one scan acquisition and still have a very good spectral quality, that we can find small particles and uniquely identify them performing a library search. If we now want to know the distribution of a certain type of polymer particle, we can just perform an integration by selecting a band that is specific for this polymer and start the integration, which you will see is also working quite fast, giving the number of spectra, and the result will be shown in the chemical imaging window. We are now able to see the distribution of polyamide particles on the filter. Again, have a closer look at the area surrounding this big particle, and we can see that there's also a lot of smaller particles around there. To highlight them even more, we're going to decrease the color scale a bit, and if we want to have a look at a spectrum, we can again just click on the particle to see what it looks like. Okay, now we've seen how easy it is to identify particles, but if we're doing this for the whole filter, this really may take some time. This is why we're exporting the data to a software called Simple, which is promoted by the Alfred Wegener Institute. The Alfred Wegener Institute is one of the leading expert institutions in microplastics in Germany. And the software is designed to identify microplastic particles based on large FTIR imaging datasets. What we see here is the Simple software. We already loaded our imaging data. We loaded a reference library that is available from a publication of the Alfred Wegener Institute free of charge. And all we need to do is click Analyze for SpectraFit. After the correlation analysis is done, you can have a first look at your sample by opening the heat map and show the correlation to a certain reference spectrum just by clicking on it. And you will be shown the correlation map for this polyethylene type, or for example polyamide. To get to the results of the analysis, we click on Run MP detection, find particles, and it will now, based on the correlation map, calculate the particle map. When the calculation is done, we can click on Show All Map, and we will be given a spatial distribution and a color coding of the particles on the filter area. By clicking on Show MP Table, we can access a list of all particles that have been found. The information available includes the coordinates, the polymer identity, the number of pixels, which corresponds to an area on the map, the major and minor dimensions of the particle, as well as its volume and its estimated mass. I hope I could give you a good overview of the analysis of microplastic particles on an anodisc filter with the LUMOSII V2 FTIR imaging microscope. Thank you for watching, and I hope to see you again.